All right. So, no viewers. Okay. So, the question is, what if I lose both my arms in a car accident and pull out this thing in competition? Could I use my tongue? Yes, you could use your tongue, but ideally, hopefully, you can have this in your head. That would be the key. The key is to try to mentally understand how to move the beads. So we have our 1, 2, 3, 4, and then we have 5. How do I know? Because this horizontal bar is what's counting the beads. So these are the beads, right? These are the blue beads, and these are the green, yellow, orange, and red beads. These beads all are counting. Hello, everybody. Welcome, welcome, welcome. Welcome, JBL. Okay, so how do I know I'm counting this bead? I'm counting this bead because this bead is touching this horizontal bar. This horizontal bar tells me that these beads are counted. So we're going to count 5. How do I know that's 5? 5 is always going to be the top bead, no matter what. This will be the top bead. But we have our top bead, and then we have our bottom bead. This bottom bead has a value of 1. So we have 6. This is 6, 7, 8, 9. 9. So how do I know what 9 is? Because this 9. 5, 6, 7, 8, 9. Welcome, everybody. Welcome. I hope you guys are all ready to do some mathing on a Sunday night. Well, it's Sunday for me. I'm not sure what it is, what time it is, what it is for you guys. But we're going to be mathing. What kind of mathing are we going to do? We're going to be mathing with the abacus. Welcome. Hey, Lady E. How's it going? Hey, Jay. How's your abacus? Sorry. I just think it's still very funny. Okay, so so we got 9. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. So this is 9. How do I know? Because we have 5, 6, 7, 8, 9. Good morning, 6:30 a.m. Thank you so much for letting me know. I do appreciate the time because I want to know like what time it is. Thank you so much. So it's Monday morning for you. Right, Monday morning. Hey, I have a question. Lady E, do you guys do daylight savings? That's a question because we still do it in America and I don't know why. Oh, that one mom. Hey, Bleeding Star, welcome, welcome. We are talking about the abacus. We are going to be reading the abacus. So what are we doing? We're reading the abacus. Enough about the chit chat. So what we're going to do is 1, 2, 3, 4. If you notice, this is 4. Why is it 4? Because it's touching the horizontal bar. When my beads are touching the horizontal bar, we know that this is being counted, right? So then we're wondering, well, wait, what about 5? Well, 5 will be the top bead no matter what. The top bead will always be 5. Now, why do I say the top bead and not the blue bead? I say the top bead because if I had this one, there's no blue. just that. Yeah. So in comparison, this abacus is the same thing as this abacus. It's just this is more colorful. So it's kind of cool because, I'd like to use it for the preschoolers and for the younger kids. But if you're willing to learn the abacus, you can use something like this. This is a 13 column. But wait, there's more. Hey, Random Acts of Kindness. That's a cool name. What's the best age to start learning? Honestly, I started my students at 3 years old. It depends on the maturity of your child. If you want them to start at 5, you could start them at 5. In my school we did start the kids at 5, but I like to start them a little bit earlier because they're about 3 or 4. That's what this book was for. This book was to help them understand the numbers and then also recognize the beads. And so it was like a 1-to-1 and trying to get them to understand. I hope that answered your question. Let me know if you have any more questions. Here's a question for you. Oh, that one mom. How old are the kids? There's been talks, so I've been kind of mulling around in my head to make a more adult or young adult workbook for students that are already know their numbers and stuff, but they want to be stronger in math. And so I'm still outlining that sort of I'm still outlining that sort of abacus, and it'd still be an introduction to abacus, but the questions would be a little bit more always complainer welcome. How's it going? I see you. A loaf of breadison. Interesting. Okay, so we are counting on the abacus. That's what we're doing because I get lost in thought. So this is an abacus. It's a counting tool. This counting tool is simple to use, easy to understand. So how do I understand this crazy thing? Well, it could be a skateboard, but it doesn't. No, or it could be a massager, but it's kind of small. No, that's not what it is. It's a counting tool, and this counting tool is a mathing tool. It's a math tool, just like a math manipulative, right? So why are we going to do? We're going to start counting. We have 1, 2, 3, 4, and then not like not like the counting tool at Target. It's still a counting tool, and it's still an abacus. I told, yeah. Anyways, it's still, it's no, it's perfectly fine. But you know what though? You know what though, Jay? Just so you know, you can graduate to this one. Either you graduate to this one, or you can graduate to this one. It is up to you. But you know what? When I start the kids on this, sometimes I'm not. You know what? Honestly, not to knock those abacus at Target, it's actually a really good starting point. And then just have them graduate to either something like this or something like this. So I started my students on this, because that's what I know. And then he's going to graduate, I think after he understands like the fundamentals, he's going to graduate to this, and then he'll feel like he's a big boy. So it's the perspective on how you take your abacus. Everything is a learning. Everything's learning, right? Okay, so we're back to here. We're counting. We're counting. 1, 2, 3, 4. So that's why I was doing this, because this is the same, right? We have the top bead and we have the bottom beads. So these are the bottom beads and this is 4. So the reason why I'm having 2 abacus is to show you that they're the same. It's just one's just more colorful, and then they both function the same. So when all the beads are touching the beam, so they're all connecting, right? Those are 4. This is 4, and then this is 5. So we know what 5 is. Are we okay? We're okay with 5. And then we have 6, 6, 7, 7, 8, 8, 9, and then 9. Okay, if I'm going too fast, let me know, because I know I talk a little fast because I've been doing this for a little bit. I've been doing this for a little bit. Oh my goodness, Witch, I really like your, I think it's Witch. Oh, thank you so much for the heart. Mother Grimm, thank you so much. Hey, Witch, I like your font. That's a really cool font. Okay, so any questions? We're still counting. So what we're going to do is, wait, I want to know what happened to 10. So what's 10? Just like how we write, we have the 10. So what do we know? We know that this is the ones. I'm going to start using this. Hello. Hello. So we're going to start using this. This is the ones. How do I know that this is the ones? Because if you notice, there's a little dot. This dot is like my indicator. This indicator, oh my God, my camera, sorry. That's like a whole blown out kind of a thing. No, come on, come on. Okay, that looks a little better. So here's my dot. This is my indicator. My indicator, thanks for the lesson. Off to bed. Have a good night. Have a good night. Thank you for joining. Thank you for the heart. Okay. Ooh, there we go. So this is my indicator. My indicator is this dot. This dot, if you notice, there's 2. You can either choose this one or this one. It doesn't really matter. What you could do is just label one of them. I'm going to choose this one because then I have a lot of beads over here. That means I have a lot of digits. Now, what does it mean by having a lot of digits? Well, this is my ones, this is my tens, and this is my hundreds, my thousands, and my 10,000. So this specific abacus only goes up to 10,000. However, now I have a bigger abacus, and this is 13 columns. This one can go either to 1,000,000 or it can go to 1,000,000,000, depending on which dot we're going to use. So either we use this one and it'll be 1,000,000,000, right? 13 columns, or we could start in the middle and it'll be 1,000,000. Ones, tens, hundred, thousands, 10,000, 100,000, 1,000,000. $1,000,000. Oh, I need this hand, right? Just like Dr. Evil. $1,000,000. Okay, so what am I thinking? Oh, I'm thinking 1, 2, 3, 4. So the reason why I'm using this bead is because then I have all these numbers that I can call, right? So I have 4 and then 9. Notice there's 9. I'm going to use this one because it's nice and colorful, and it's probably easier to see. It's probably easier to see on the camera. So we have our 9. So when we look, we have this number, 5, 9, 4. Let's do 1. And there we go. So here's a question. If this is my ones, what number is this? Please put in the chat. Wow, thank you for the hearts, everybody. Okay, so we have our ones, our tens, our hundreds, and our thousands. In the chat, what number do you think this is? Do, 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 do. I don't even know if anybody knows that, right? Like, I know, like, I'm old, right? So it'd be all the old people knowing the do, 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 do. Hayden, let's see, 1,500, almost, Hayden, because we got the 5 here. Yes, yes, it's Jeopardy. Thank you, Alma. 220, not 7, 9. 5, 6, 7, 8, 9. Yes. So Hayden got everything except for this one, and then Alma got everything except for this one, and then Jay got Jeopardy, right? Jeopardy. Oh, hey, Jose the Panda. 1,529. Exactly. Exactly. That's what it is. 1,000. But so now if you look, there's a dot over here. If you notice, that dot will help us write it. Whoa, let me get a thing. So what is abacus? Abacus is the gateway to complex math. That's what an abacus does. Why? Because we have formulas that we need to understand. But before we know all of this, we should understand. Thank you for the follow, Jose. What we need to do is we need to understand how to read the abacus. So I'm going to write it out. And if you notice, there's the comma. This comma helps me figure out when we write it. So this is 1,529. Yes, thank you, Hayden, for the follow. Thank you, Hayden, for the follow. Okay, so if you notice, that's why we have the dot. So this dot helps me see that I'm at the 1,000. Just like if I did this one, right? If I did this one, and this is my ones, I know this is my 1,000, and then over here is my million. So it's easy to see instead of having to count. Oh my God, what am I counting, right? Ones, tens, hundred, thousands. So because we have the indicator, it's easier to see. So it's just nice to label things, right? Not categorize, label, right? We're okay here. So, but wait, there's more. What do you mean there's more? Well, we have a decimal. What does the decimal mean? Well, notice when we do a decimal and say, let's say 25 cents, right? Let's say a quarter. We're going to be a quarter. So if this, we said that this was money, right? We have 1,529. And then if you notice, the decimal does not sit anywhere. It sits between the ones and the tenths. So we know this because we work with money, right? The decimal happens to be in between the ones and our tenths, and then it goes to our hundredths. So when I say 25, that's a quarter, right? You know that. Make sense? Are we okay? Everybody grooving? Everybody mathing on a Sunday night? You guys are so silly. I can't believe 18 people wants to math on a Sunday night. Monday morning for Lady E. I don't know if... Wow. Okay, good. We're all good? Yeah, great. Okay. So the first thing we're going to do, this is the first thing to do. And that was the reason why the book was made. The book was made to continue on to understand, I'm at work. I'm having a great time listening in. Whoa, yeah. Thank you so much, Siran. Yes, thank you. Hopefully, I don't bore you and I put you to sleep at work because I don't want to do that. Okay, so that's why we're trying to do is we're trying to understand what does the beads mean and how do they look. So that after we understand all of that, we understand. That's not a problem. Okay, you know what? Let's do more. How would you use it to add and subtract? Mac, that's a good question because I was about to get to that. You read my mind. All right. What we're going to do is we're going to go through all this stuff. So this was just adding, subtracting, and... No, this is not adding, subtracting. This is about talking about the relationship, right? Hey, Sammy, thank you for joining. So the first thing we're going to do is we're going to learn how to add. What we're going to do is we're going to add the one bead. Now, why are we going to add the one bead? Because abacus is all about the process of adding and subtracting, the add-in and the subtracting. Okay, and that was the one thing that I noticed, that in school we focus on the result, but we don't focus on the actual add-in itself. So here, if you notice, and we're going to do really simple for right now because I don't want to, because it's fine, right? It's good to go simple because as you wrap your head around understanding how to read the abacus, it will be easier to understand. If I give you really big numbers and then you also have to understand how to read it, it's not good. So we're going to do really simple numbers. This is not to insult anybody. This is just to understand, the basics and the fundamentals of abacus. So the first thing we're going to do is we're going to do 1 plus 1. We know this. Why? Because in school we were told to memorize. But in abacus we're not memorizing. the doubles. What we're going to do is we're going to start memorizing how our beads move and what it all means. So what we're going to do is we're going to do, oh, not there. We're going to go over here because you can see it. So I have my 1, and then I have a +1. So notice I'm just moving 2 beads. That's fine. So my answer is 2. That's good, right? We're okay. So then notice what I'm going to do is I'm going to start subtracting. I have 2 and I take away 1. So now I know when I remove the bead away from the horizontal bar, I know I'm subtracting. Now it's interesting because when in Abacus, we actually show adding and we subtract. So when we add, we know to subtract. The reason why is because, thank you so much for the follow, Mac. So what's the difference is in school, they don't teach subtraction until later, but also in school, they push recognizing the numbers faster than understanding the concrete, the physicalness. So what we do in Abacus is we always go through the whole question. No matter how big the question is, no matter how many numbers there are, we always do it through the Abacus first. So when we do it through the Abacus first, we see how the beads move, we get an idea, we see a rhythm, we see the number patterns, and then we can start doing it mental math if that's the path you want to go. For me, I don't do mental math. I'm just saying. I can talk about it, but you know, when my kids start doing it, I'm like, whoa, hold on, hold your horses, slow down, let me see what you're doing. So you can do it mentally if that's what you choose to. Okay, so again, going back to this. So now the next question over here, what we're doing, we're going to do 2. How do I know? Because there's 2 beads touching this beam. I wanted to go from a representation, which is the picture of the abacus, right? The picture of the abacus, to the physical abacus. So there's my 2. And then I want to add the 3. I want to add the 1. So I'm going to add the 1 bead, and then I add the 1. Not a problem? We're good? Right? We're just adding. We're doing simple adding for right now. So what this is just showing that we're adding the 1. Now, the reason why I have the different scenarios of adding the 1, because I didn't want the children to be hung up on which bead to use. They're not only going to use the green bead. They're going to use any one bead that's on the bottom. So that's the key, right? The key is to be flexible with the amount of digits that are out there. So the next number obviously would be +2. So we add the 2, right? So we have 7, and then we add 2. So notice I'm going to add these 2 beads, and it makes, what number is that going to make? Please put in the chat what number that makes, because I can't be the only calculator in this world. All right. Yes, thank you, Jose. 9. Thank you, Amma. 9. Yes, Jay. Okay, so easy, right? So simple to use because it's easy to, and it's easy to understand. So we done +2. Now the reason why we're doing it by the add-ins, right? Thank you, Albie and Mac. The reason why we focus on the add-ins. We focus on the add-ins and not the result. Because, why? Because we get it to one step further. Thank you for the follow, Kay. We're going to go one step further. Now, what does that mean? Well, one of the things was I saw this one video and they're like, okay, let's work with the number 8. And I'm like, okay, let's work with number 8. And they're like, let's do 5. Okay, what does 5 look like? That's what 5 looks like on the abacus. But we know what 3 looks like. Okay, we add 3. Notice on the abacus, we add the 3. There's enough beads to add the 3. Because we need to know the process and not the answer. Yes, exactly. In abacus, we need to know the process. And so one of the things was, there's my 8, right? So one of the things was, and they kept going. The next one was 7 + 1. So now I have to go back and I'd be like, okay, 7, and then we add the 1. So what we're going to do, we're going to add the 7, and then we're going to plus the 1. But they're different add-ins, right? You see that. They're different add-ins. So then final number, right? The final answer, which was 4. And I'm like, what? What do you mean 4? We know in school we were taught that we needed to memorize our doubles. And I'm like, you know what? Screw the doubles. Doubles are bullshit. I don't know if I'm supposed to swear on TikTok. Okay, BS. So learning the doubles. So the process is important because it maintains the definition and the result or the answer. That's correct. And so if you don't do the process correctly, your answer will be incorrect. So we know that if the answer is incorrect, then our process was incorrect. So it's kind of like a thing, right? So here's the thing. Here's the question. The sample question was 4 + 4. So in the video, there was 4 + 4. It's like, okay, great, 4 + 4. We memorized it. We like to swear. I don't know if I'm supposed to on TikTok. I don't know. I don't want to get banned and I don't want to get restricted. And then I don't know if any kids are here. So, because I know some kids are watching, even though it's a little late. All right. So, why? Because we're talking about the Abacus and its accounting tool, and maybe the kids are seeing. But, okay. So 4 plus 4. 4 plus 4. Now, the question was 4 plus 4, and we memorized 4 plus 4 is 8. We all memorize this, but you know what? Whatever. But in Abacus, if you notice, I don't have enough beads to add the 4. Now we're getting to a situation. Now we're getting into the formula. This is a fundamental building block that you need to memorize. This is the one thing we need to, this is the few things that we need to do is to memorize. And one of them is to understand a formula. The understanding of the formula is plus the 4 is equal to plus the 5 minus 1. We're going to do minus 1. What does that mean? Well, hey, Gina, thank you for the follow. Okay, so what does that mean? So in school, we are teaching children how to make a 5. Now, here's a question to everybody. What ways to make a 5? How many ways can you make a 5? Let me know in the chat. Thank you for the hearts. Woo! I got 1,000 already, 1.6 Ks. Wow. All right. And 100 diamonds. Woo! All right. Oh, that's my dog. Okay. Yes. Thank you, Jose. 2 plus 3. 2 plus 3. This is what they're teaching in school, and it's great. And 3 plus 1 and 4 plus 3. Yes, and thank you. 5 plus 5 and 5. Yes. Great. Ooh. 4 plus 1 is equal to 5, and so forth. Great. Thank you so much for the, yes, good. So we all know how to make a 5. We all know how to make 5. Not a problem. What the Abacus does is we actually take it one step further, and we make it, we use it. We use it. What do? We're going to take this 4. We're going to isolate the 4. This is a very bad looking 4, but we all see that it's a 4. We're going to take the 4 and we're going to move the 1 to the other side. So we're going to isolate the variable. When we isolate the variable, I'm going to rewrite it so then it's better. 4 plus 1 is equal to plus the 4 is equal to plus the 5 minus 1. That is what we're going to do. Distribute. Okay, we can distribute. Distribute. Is that what it is? See, I don't know the fancy schmancy terms. I just know how to do it. I just know how to memorize. This is what I need to memorize. So what are we doing? We are adding 4 plus 4. 4 plus 4. That's what we're doing. We don't have enough beads to add the 4. So now what we're going to do is we're going to utilize this formula. This formula is plus the 5 minus the 1. So we add the 5 and we take away the 1. So we just used a concept and made it, and we just used a concept, making of a 5 and utilizing it to a higher level. Higher level? 2 plus 2 plus 1. Yes, Patty. We could do that. But then if you notice, we have 2 plus 2, so we have 4, and then we need to add the 1. So when we add the 1, we still need to figure out how do we add the 1. So why are we doing this? The reason why we're doing this is because we want to utilize the 5. When we utilize the 5, then we do a lot of math. We can add more with our numbers. So we have 4, and then we have another 4. To do another 4, we have to plus the 5 and then minus the 1. All right? Hey, thank you. Thank you for the follow. Thank you for the hearts. Okay. So when we talk about formulas, these are the things. So let's take it one step. Let's take it for another step, right? The next one would be 3 plus 4. So 3 plus 4, that was a horrible 4, but you know what I mean. So notice we have the 3 and we want to add another 4. We can add a 4. How do we add a 4? Well, to add a 4, we have to plus the 5 minus the 1, just as we learned up here. Plus the 5 minus the 1. What if we were at 9 plus 3? Haha, thank you. That's the next one. So the next one would be to actually understand how to make a 10. So here's a question. How do you make a 10? So that's another thing that school is teaching us. The school is teaching us, rest easy, Peter. The school is teaching how to make a 10. We do 9 plus 1 is equal to 10, right? What's another way? 8 plus 2 is make a 10. we're going to take it one step further. The question is excuse me, 9 plus 3, right? So we have 9. Sorry. We're going to have 9. We have 9, right? We have 9. Now I want to add the 3. The question is, can we add a 5? No. So we cannot add a 3. We cannot add the 5. Well, what the heck can we do? Well, what we can do is we can add a 3 when to use a 10. So plus the 10 to make a 10 with a 3, it's plus 7 and it's equal to 10. That's what we can do. Now what are we going to do? Is it distribute? I don't think it's distribute. I don't know if it's distribute. Isolate and cancel. What do I want to do? I want to take the 7 and I want to move it over here. So I'm going to rewrite it. When I want to add the 3, I'm going to plus the 10 minus the 7. Transpose. Isolate. It's isolate because we want this one, right? But I don't know if we're transposing. This is an algebraic term that I don't know. Cancel. I don't think it's cancel. Okay, so we're back to here. What does this mean? This 10. This 10 means I will always go to the one column to the left, no matter what. That's just a hands down. It doesn't matter if I'm at 1,000 or 3,000. I'll explain that in a bigger number. But for what now is what I want to do is I want to add the 10. So I'm going to add the 10, and I need to take away the 7. So I take away the 7. So Jose, my answer is 12. I just told to move it to the other side. Yeah, rearrange. Yeah, I don't know. See, what I'm trying to do, the reason why I'm having problems with formulating my math terminology is because I want to popularize Abacus. I want Abacus to be more mainstream. So my question would be more like, how does algebra talk? Because I know algebra talks about isolating the variable, and we also substitute. So what we could do is we substitute this equation into here. So we do a lot. We do a lot, right? So we isolated the 3, then we substituted this formula, the number sentence. That's another terminology that's being used in mainstream math. The number sentence, or sentence sisters, or so forth. The reason why, and that was the one thing, is like trying to find the terminologies that's being used in mainstream math. That's where I'm at. Why? Because in Abacus we don't talk like that. I'm just saying. In Abacus we just call it friends and big friends, family, big family. Sometimes we call it the plus 5s. Sometimes we call it the plus 10s. But in Abacus we don't use like big terminologies. We just say, do the work. But I'm trying to mainstream Abacus. I'm trying to mainstream it and just trying to math facts. This is a math fact, yeah. Yes, this is a math fact. You're absolutely right. I think, Jay, you were right about transposing. I don't know. Yeah, I don't know. That's really cool, Jose. When I was asking, I was thinking about the 10s and the 1s. Yeah, exactly. So the 10s and the 1s, so it's very, very, it is interchangeable. But like, see, okay, so let's take it one step, right? Let's say it's 90 and 30. We don't say add the 100. We still bring it down. We still decompose it. Why? Because on the abacus, right? On the abacus, I'm going to do it this way. 90 plus 30. The reason why we don't say 100 is because the abacus already shows us the columns. So we don't need to say plus 100. We don't need to say that. What we say is plus the 10 minus the 7. We don't need to say plus the 100 minus the 70, because then it just gets complicated. It would get complicated really quick. So what we do in Abacus is we boil it down to the simple, like the least common, is it the least common factor? It's the simplest form of the formula, simplest form of the sentence. So what I would say is, because this is 90, I want to add 3. I'm looking only at the column. I'm only looking at the column. I'm not looking at the 0 because the zero's already there. That's too much information. So what we're doing is we're focusing only on what we're trying to do. So here we're adding the 3. I only want to add the 3. To add the 3, I only want to plus the 10 minus the 7. So then my answer is 120, right? So at the end is when we start looking at our answer to figure out what our placement value is. I just rambled on. I don't know if that was okay. Math facts. Yeah. It's a math fact. It's a number sentence. There's a lot of terminologies in mainstream math that I'm still trying to get a handle of. I mean, I have my boys and they all gone through school, but they never needed my help because they already knew abacus. So I'm a little bit lacking in the math terminology. So any other math teachers or kindergarten teachers that are out there that want to explain to me like some of the things, I'm all for it. I love discussing about all this stuff. So so that's the one thing is in school in abacus we do our formulas. We have our making of the 5 formula, and then we have making of the 10 formula. So going back to the making of the 5 formula, we have our set. So our set is plus 4 is equal to plus 5 minus 1. Why do we say plus and minus? Because we want to be reminded. We're reminding ourselves that we're going to add the 5 and take away the 1, right? When we do the 3, plus the 3 is equal to plus the 5 minus the 2. Plus 2 is equal to plus the 5 minus 3. And plus 1 is equal to plus the 5 minus 4. These are the formulas. See, in abacus we call it formulas. I don't know if you would call it math facts. Maybe math facts. I'll keep a note of it. Math facts. Yeah. I don't know. It still eludes me with all the terminology. So going back, algorithm could be. I think. I don't know. I don't know. Maybe algorithm. How do you know which column to use in the abacus? Oh, I have an indicator. So in the indicator, that's where the dot is. When I was talking, I talked really fast, so I understand. And so here, if you notice, there's a dot. So you could choose either this one or this one. It doesn't matter. You just need to choose one of these indicators, these dots, these labels, to figure out where the ones place is. So for here, if I said this one, it'd be ones, tens, hundred, thousands, 10,000. Or if I wanted this one, I could be like ones and tens. And then because I have my ones and tens, then everything else after this side, it'd be the decimals, right? So it'd be tenths, hundredths, thousandths, right? And then 10,000ths and million. So, Jose, love it. So let's do it. 11 plus 5. Easy. That is what you call a simple. Why? Because there's enough beads to add the 5. If that makes sense. So in abacus, we actually have a set of, there's a pattern. There's a pattern, and abacus really shows it. So if you notice, we had the, I don't have 11 here. But if you look at it, it's 1 plus 5. 1 plus 5, it's kind of like 11, right? 11 plus 5. So this here, if you notice, is our simple, meaning that there's enough beads to add. Then we did our plus 5. Our plus 5 is the stuff that we need to utilize the top bead. That's what these are. These are adding the 5. This is what we're doing, is we need to utilize the 5. The next thing we need to do, after we understand how to make the 5, is we're making the 10. After we make the 10, then we go into a 2-step equation. I don't know. Are we ready for a 2-step equation? Are we okay with our 5s and our 10s? Hey Mal, you're here. Good to see you. Oof. No. Okay. So let's start going with let's keep with our 10s, making the 10s. I'm ready. Are you ready? Okay, I'm ready. Oh, you know what? We could do minus. Let's do minus. Maybe we'll do some minusing. So again, it's easy, right? When we look at it, we have 8. So I go 8 and I take away the 2. So I take away the 2. That's what we do in this one. We do simple abacus here. So notice I have my adding. So we add first, and then we subtract. So we subtract by the add-in, right? I'm breaking it down to add in to do the add-in. After we do a subtraction, then we do more adding. So adding is the plus the 5 plus 6 plus 7 plus 8 plus 9, and then we do the takeaway. Take away 8, take away 5, take away 6, take away 7, take away 8, take away 9. So Jose says 13 minus 6. Let's see. 13 minus 6. guess what? You got the two-step equation right there. Why is it a two-step? Let me show you. Let me show you the two-step equation. All right. Or maybe Jose knows and he's just like joshing me. Like he knows abacus because he was ready to do a two-step equation. He's just testing me. So we have 3 minus 6. All right. 3 minus 6. I'm sorry, 13 minus 6. We have 13 and then we take away the 6. Nah, I'm just trying to learn. Are you sure? Because that's a two-step equation. You're like so ready. Like you know this. Okay, so what does that mean? I want to take away the 6. Notice I have my 13, my 1 and my 3. I want to take away the 6 over here. So in this side, I want to take away my 6. This is where I want to take away my 6. Notice I don't have enough beads to take away the 6. What do I do? Well, I know if I need to minus the 6, I used to play with 1 when I was a kid, but never was really told how it works. Oh, interesting. Was it always this one, or was it the 2 and 5? Or was it 10 beads across? What did your abacus look like, Jose the panda? So we're still doing this. I never knew that it had dots. Oh, it might be the Chinese one then. It could be this one. I don't know how old you are. I'm assuming you're my age, and I'm like kind of old. So there's this one. I don't know if you had this one. Oh, you're young. So then you might have had this one. Okay, so going back to this. Minus 6. Oh, really? So this is the Chinese one. The Chinese one is a little different. It still has the 5 beads. These are the 5 beads. This is 5, this is 5, and then this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then that's 5, this is 5, that's 6, 7, 8, 9, 10. That's 10. This is 10. And this is 10. Then we have 11, 12, 13, 14, 15. We have 15 or 15. Or yeah. Yeah, so that's how we do. Okay, so we're back to here. So we want to do is minus the 6. Okay, suspense over. Suspense is over. Minus the 6 is minus the 10 plus the 4. So if we look, we want to minus the 10 and plus the 4. Minus the 10 just means you're going to go from one column over, right? So we're going to minus the 10 and we're going to plus the 4. When I plus the 4, notice I don't have enough beads to add the 4. I have 3 here. What do? Remember our formula for making of the 5. Plus 4 is equal to plus the 5 minus 1. This is why it's a two-step, because we take this and we associate it or substitute that into here. So we have to plus the 5 minus the 1, plus the 5 minus the 1. This is where it's solid. You only need to know how to make a 5 and how to make a 10, and you're solid and you're gold. You just need to figure out how do they all fit together. And so my answer is 7. We good? We good? We're okay? Make sense? So this is why it's a two-step equation. It's a two-step equation because we had to fit one into the other. Hey, Jeremy Clark. Thank you for the follow. Let's do another one. Woo! So, are you learning the bead flow to make the... Okay. So, you are learning the bead flow to do the... To do makes A's. To do the make A's. Yes. So what the abacus does, I believe I understand what you're saying. What the abacus does, it keeps track. Make a, yeah. The abacus keeps track of your numbers. That's all it does. But you have to do it in your head to figure out how to move the beads. Yes, exactly. Exactly. So learning the abacus is really just seeing the beads and how they move. But knowing the formulas, knowing how to work the equations is what makes it special. But what it makes it to go to the next level, which means like it will prepare you to critically think. It prepares you to critically think for higher thinking math, if that makes sense. So Abacus, this is why Abacus is a gateway to complex math. Why? Because when we look at a problem, you seem like such a kind person. Oh, thank you. My kids don't think so. um, so what I'm trying to say is when we look at numbers and when we look at the questions, like when we're adding and subtracting, multiplying and dividing, we go through steps. There's like a little checklist that goes through my head when I go through. And when you figure out the framework, when you have a framework, I'm sorry, when you have a framework, then you know how everything would fit. It's like fitting a puzzle or learning how to use Legos, right? You have Lego pieces. You can build anything with Legos, but as long as you have the pieces and you know there's a like a square Lego piece and a rectangular Lego piece, you know what to do with it. It's the same thing with understanding how to make a 5, how to make a 10, and when we do multiplication and when we do division. Tabby, this is great teaching. Yes, thank you. Thank you. I appreciate that. Hopefully it all makes sense. Let me know if you have any questions. But yeah, it's one of those things, and that was the other thing. Is like, like in Karate Kid. I don't know if you guys seen the old Karate Kid, right? I don't know if did the new Karate Kid do wax on and wax off. I don't remember with Jaden with Jackie Chen. I don't know if he did the wax on and wax off. It's the same thing with Abacus, right? With Abacus, knowing the formulas, knowing this is like waxing on, and then let's wax off, right? So what we're gonna do is we're gonna wax off. We're gonna wax off. We're gonna wax on. We already know plus 4 is equal to plus the 5 minus 1. Now, what about waxing? Why, add about waxing off. Waxing off is minus 4 is equal to minus 5 plus the 1. Minus 3 is equal to minus 5 plus the 2. Minus 2 is equal to minus the 5 plus the 3. And minus 1 is equal to minus the 5 plus the 4. Right? So this is like, when we add, we will subtract. That's how we do it. Because we need to know how to add and subtract, we balance the equation, right? We balance our understanding, and we know how to use it. So just as we did here, minus the 6. So what does that mean? Well, this is making up the 10. Making up the 10 is the same thing. So we did like 5 plus 5 is equal to plus the 10 minus the 5. And then 6 is equal to plus the 10 minus 4. And then there's the opposite, right? 4, the inverse? I don't know. This is where they start talking about like sister sentences or sister siblings or whatever. But in Abacus, we just memorize it like this. Woo! Let's do another one. Oh, good. Oh, let me show you that. So let me do 7 plus 7 is equal to plus the 10 minus the 3, or 3 is equal to plus the 10 minus the 4. Sorry, minus the 7. Okay, there's another question. Thank you, Jose, for all the questions. I do appreciate it, because then I don't have to think about it. So 32 take away 14. Now, in regular school, we were taught what? We were taught to do our ones first and then do our tens. We don't do that in Abacus. What we do in Abacus is we go from left to right, like how we talk. So we have our 30 and we have our 2. We take away 1 because we're taking away 1. So we take away 1. Thank you so much for the hearts. We take away 1, right? And now we take away 4. Well, what do? We can't take away the 4. What are we going to do? Oh my God! Somebody, please help! Who's coming to save the day? Minus the 4 is equal to minus the 10 plus the 6. So what are we going to do? We're going to minus the 10 and we're going to plus the 6. So my answer is, what's my answer? Please put in the chat what my answer is. Oh, I enjoy making like sounds. I'm a little silly like that. My kids think I'm kind of dumb. But it's okay. 18. Thank you, Jose. Thank you. Arantax. I think I said that. Arantaxa. 5, I think. 5? No, not 5. Because why? Because we have our 5, 6, 7, 8. And if this is my ones place, this is my tens. So this would be 1. So 18. It'll be 5, 6, 7, 8, and then 1. It'd be that. Yeah. If that makes sense. So, oh, this is just my equation. This equation is outside. This is by itself. So 18. Yes, exactly. 18. Woo. So, make sense? We're okay? Oh, I get it's 18, but I'm confused on how to read the beads. Okay, let's take a look. So, when we read it, right, the horizontal bar tells us that we're counting the beads. When we are counting the beads, what does that mean? Well, if you notice, all of these beads are 0. None of the beads are touching the beam. So, when we do that, only this column is touching the beam, so that means this is 1. So this is 2. So we have 2, and then 3, 4. Now, we don't have any more beads at the bottom, so what do we do? Oh, okay, thank you, Jose. Thank you so much. I appreciate all the questions. It was very helpful. I'll see you in my next live, hopefully. Okay, so after 4, what do we do? Well, we don't have any more beads. That's where the top bead comes in. The top bead will always have a value of 5 no matter what. That is a value of 5, and then there will be 6. How do I know? All the lower beads has a value of 1. So when I add them together, 5 plus 1 is 6. And then 5 plus 2 is 7. So I go 5, 6, 7. And then I have 8. 5 plus 3 is 8. Yeah, yeah, right? See? Easy, simple to use, easy to understand. It's just the one thing, it's just you just need to understand how to read the beads, right? So when we understand how to read the beads, then everything's golden. So then there's other things like, understanding how to, like the framework and stuff. So this is 9. How do I know what 9 is? Well, if you look, I have an indicator. Not a problem, Gray. There's an indicator. This is the dot. This dot indicates that I'm going to be in my ones. But notice there's a dot over here. So you could choose any dot to be your ones. I chose this one. I could choose this one. And that would be 9. So then what would happen? Then this is 10. So this is why this is 10. Thank you for helping me understand the beads. But I still don't get it. I get a little bit. Okay, no problem. We can continue on learning how to read the beads. So we have 10. How do I know? Because we have our ones and our tens. Just like how we write. So we have our 1. So let's say 10. 10 looks like this. So if 10 looks like that, I have my 10 in my tens column and 0 in the 0 column. So then I have 11. And then I have 12. And then 13. So how do I have 13? Well, the beads that are touching this beam, only these 2 columns. These 2 columns, 1 and 3. That's it. So, but Tabby, you understand how to read the abacus? Are we okay with that? So we have this. If we know what number that is, oh, I already did that number. What number that is? Do we know how to read that number? But don't forget, it's also two-dimensional because you're seeing it through the camera, where it's different if you actually had it in your hand. It'd be different if you had it in your hand. Right. Thank you, Gina. Thank you, Leisha. I just joined. I have to join later with square 1. Thank you. 8. Tabby. Don't combine the 2 columns. This is a single column and it is by itself. So when you're looking at it, we're only looking at this. What number is that? Tabby? So that's the one thing, making sure you don't get too confused. Hey, Ethan. 7. Thank you, Lori. Yes. Thank you so much for liking my live, Ethan. So, Tabby, when we're looking at the columns, only look at the columns by itself. So this is one number. This number is 7, just as Lori mentioned. Does that make sense, Tabby? So then, when we combine it with this column, I think you forgot to fix your hair. Yeah, that's what happens when it's late. So, okay, Makes sense. So then I think what it is maybe the columns are confusing you, and you have to make sure that you only read the columns as is. So this is 1, this is 1. So when we combine the two columns together, this makes 17. Make sense? So each column, this is a column, is its own number, and it cannot be more than 9. So this is 9, right? This is 9, this is 9, this is 9, that's 9, this is 9, that's 9. These are all 9s, right? Now they're all 9s, but it's a big number 9, right? So what does that mean? We have a lot of 9s. Let's see how many 9s. 1, 2, 3, 4, 5, 6, 7. We have 7 9s. 1, 2, 3, 4, 5, 6, 7. That's what it would look like. Blue beads are 5. Yes, Leisha, blue beads are 5. So that's what it looks like. Does that make sense, Tabby? 9, 9, 9, 9, 9, 9, 9. Yeah. Yes, Leisha. The bottom beads, yes, the bottom beads all have a value of 1. So when we look, I have a calculator. I have a calc tomorrow. Sorry, I don't do calculus. I only do arithmetic. Okay, so, yes. So when we count, 1, 2, 3, 4. This is 9, because this is 5. 5 plus 4 is 9. This reminds me of Roman numerals. Yes, yes, Daniel. However, somebody did mention that it's like tally marks. And I was like, oh, yeah, tally marks. So they were mentioning how the 5 could be a tally mark, right? So it'll be 1, 2, 3, 4, 5, and then there's 6. So then it'll be 5 and then 6. If you choose, let's see, if you choose to do the ones at the first dot and you go behind it, it'll be like decimals. Yes, exactly, Gray. Exactly. So if I did this one, this is 6, so it'll be $6.25, let's say, right? So it'll be $6.25. That's what it would be. Is it inspired by Roman numerals or tally marks? Abacus was inspired by pebbles. Pebbles started before. I don't know how. I don't know who started first, but I think the pebbles started first because they wanted to keep track of business. I don't know when Roman numerals came, and I don't know when tallies came. That's not something I think tally marks is more befitting. Yeah, right. I think I was like pebbles got it. Yeah. So that was kind of interesting. Like somebody said it, and I was like, huh. And it took me a while to like marinate on it. But yeah, I think the tally marks makes more sense because. But the thing is with the tally marks you can break it up, whereas on the abacus you can't break it. You can't break the 5. You can only use the 5. You can only use the 5 or use the 10, and that's where we get into the formulas. So that's why we have the formulas to help us utilize the 5. Yeah, pebbles, got it. Yeah, so abacus really just means moving pebbles. And it doesn't matter what kind of pebbles. It can be the Japanese one. It could be the Chinese one. It could be a Wreck and Wreck, which is a Dutch one. It can be a Target one. They're all the same. Just the functionality is just different. Can you explain the adding 5 and 10s again? Yes, not a problem. So again, in school, I can go back to like why do we talk about it? Well, we understand how to make we understand how to make a 10. No, we understand how to make a 5. So the first thing we're going to do is understand what to do. So if I want to do 3 plus 4, 4 plus 3, 4 plus 3, the question that goes through my head is, do I have enough? So I have my question is 4. Sorry. The question I have is 4. I can't wait to learn multiplication and division. So 4. We have 4. Now the question that goes through in my head is, do I have enough beads to add the 3? No. So what can I do? Well, I know to add the 3, I need to, plus the 3 is equal to plus the 5 minus 2. So that's where I talk about these cats in a tree. And I don't know if this will help you, but there's cats in a tree, and there's always going to be 5 cats in a tree. And so when I have 5 cats in the tree, so I have this question, right? 4, and then I don't have enough beads, so I go to the 5 cats in the tree. The 5 cats in the tree, I grab 3 cats, and I add my 5, right? I walk to the tree. I add the tree of the cats. I grab 3 cats, and then 2 cats run away. So my answer is 7. You go up to 9. Rocio, you only go up to 9 for a 10. You need 2 digits, or in this case, 2 columns. That's correct. That's correct. I'm sorry. Did I miss a question? Can the plus 5, but you cannot 3? You can plus the 5, yes. Then you cannot minus the 3. We're substituting the formula. So what we're doing is we have 4. We want to add the 3, but adding the 5 is too much. So when we add the 5, it's too much. So what we have to do is we have to minus 2. That's the formula. When I want to add the 3, I have to plus the 5 minus 2. Yeah. So that's why we need to understand how to make a 5, because we want to utilize the top bead. When we utilize the top bead, we want to add the 5. But the problem about adding the 5, it's too much. So, okay, wait, I'm sorry. There's all these comments and I'm missing stuff. So, okay, I'm at to show the formal written out like the other night. So, okay, I will. Okay. That was this. All right. Thank you, user. I just see user 188, but I remember 188. All right. But thank you so much for reminding me. Yes, yes. So, cause like we had the 5, all the other. So like, cause we had the 5 and all the other 4 would be 9. I don't know what that means. Sorry, Gray. So we had the question was 3 plus 4. Was that it? No. It was 4 plus 3. So we add the 4. Right? We add the 4. We don't have enough beads to add the 4. So what do? We know we know our formula, we know how to make a 5. To make a 5, now we're going to isolate the variable. When we isolate this variable, because that and this is the same, right? What we do is we're going to move this 2 to the other side. So I'm going to rewrite it. I'm going to rewrite it to be plus the 3 is equal to plus the 5 minus 2. So, okay. Oh, oh my goodness. Oh my goodness. There's a lot of comments. Gray, the blue bead is 5, 5. Ones on the bottom are 1. Altogether is 9. Yes. Like on the bar, if I had the 5 bead touching the bar and the other, yes. So if I had the 9, that's what the 9 looked like. Yes. So do you mean in all 4? Yes. The blue bead's 5 and all the others is equal to 9. So this is 9, this is 9, this is 9, that's 9. Yes. Oh my goodness, the cats in the tree just makes sense to me. That's a great concept. Yes, thank you. Oh yeah. Yeah, that was the one thing. The reason why I said cats in the tree was because the kids are small. The kids were, I'm guessing, going to be 4, 5, and 6. So sometimes getting to understand how to use the 5 for the cats in the tree might help them. Okay, so Grace says, okay, so that's why we have to get rid of 2 because we need 7. Are we on the same? I'm not sure if we're on the same. I'm not sure we're on the same question. We need to get rid of 2 because we need 7. We need to get rid of 2 because we added the 5. See, it's not the 7. It's not because we need the 7. We're not looking at the result. We're looking at the process. So the process is making sure we understand how to add the 3. So it actually doesn't matter. It could be 3 plus 3, right? When we do 3 plus 3, the question is not how do I make a 6? The question is what do I do with the 3? So the 3 in this concept, in this scenario, I want to add the 3. I don't have enough, so I have to go to I have to go to the 5. I got to add the 5. But adding the 5 is too much. I need to remove 2. So, previous. Oh, okay, previous. Okay, good. So there was 7 in there, but you only had put 4. The phone glitched. Okay, so the previous one was 7. This one, 13. 13 take away 6. There was a lot of previous ones. Yeah, I think it was this one, right? 13, but that's what I meant to put. On the 7 rows of 9, she only put 4. Oh, this one? So if we're doing 9, so, but that's a different one. That's making of a 10. So we have 9, right? We have 9, and we take away, and we add 30. When we add 30, we're using a 10, but 10 is too much. Yeah, I think I have to start over. Okay, yeah, I think so. I think I need to start over because there's a lot of going on. Thank you, Jay. Yes, I will start over. So let's start over. Yeah, I think there was too many questions. Okay. Here they go. Clean. All right. So let's do it. So the first thing we're going to do is we're going to count. 1, 2, 3, 4. No, don't be bad. No, 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 don't be bad. This is not, no. Because it's different when you're texting as opposed to having a conversation. We're having conversations. Don't be bad. So we have this, right? 4, and then we have 5. We have 5, 6, 7, 8, 9. And then there's 10. I just need to 4. Yep. So that's 10. Because don't forget, everybody comes in at certain times. That's 5. That's not 5. This is 5. See, so that's 5. When people come into the room, sometimes I'm in the middle of a concept. And when I'm in the middle of a concept, it's hard to keep up. So it's always good to start from the beginning. See? Abacus is very confusing. Abacus is not confusing, Ethan. Simple to use, easy to understand. It's just, it's harder when you go into a middle of a conversation. So put in 5. Yes. Then I put in 5, but you changed it. You change it to 4. Yeah. 4. Okay, I'm going to take it slower because I talk too fast. Okay, put in 5. I'm going to put in the 5, and then I put in the 5, but then you change it to 4. And then I added the 4. I think most people don't realize where 0 is and then where the decimal point is. It could be that too. So here I'm at the 0, right? Because I have my decimal, I have my dot. This is where my indicating is. So texting takes time in the process to receive. Yes, and that's why after the text she's already answering another one. Yes, exactly. That's why I got to take it slower too because I'm also talking like super fast. So we have 9. Then we have 9. So when we add the 9, I'm going to add the 4. That's my 4. So now I have 9 altogether. Yes. So we have 9. So we had the 5 and then we had the 9. And then we're done. So then after 9, we have 10. Hey, Daryl. Yeah. So after 9, yes, so now we're at 9 again. Yes. And then after 9, we have 10. How do we get to 10? So we get to 10. Okay. This is my 1s. This is my 10s. So I just add 10. So I'm going to make it 10. That's a 10 and a 1. What did this look like? This was 19. Because it's 1 and a 9. You add 1. I add 1 to the 10s column. So when I add 1 to the 10s column, just like just like how we write, right? But if we put it in a box, they also teach this in class, right? This is my tens, this is my ones. Does anybody remember boxes in their... Anybody remember boxes in school? So then they had hundreds, right? There was a hundreds box. Same concept. So we have our 1, but we need a 0. Same thing with abacus. This is 0, and then that's 1. My hundreds is in this box. So I'm going to put 3 here. So I have 3, 3. Oh yeah. Yeah. No, this is now we're talking about place values. So one of the things on abacus is we understand place values. We don't need to worry about place values as long as we look at our numbers. So here my number is 310. This is good. Lining up writing in the beads. Yeah. Yeah. It's just trying to understand where the disconnect is, because I don't know when people come in. So one thing is to also understand, like when I want to add the 5, so I'm going to add the 5. How do I add the 5? Well, it'll be here. So it'll be 3, 6. How do I know this is 6? So it'll be 361. Let's do that. So this is my ones box, this is my tens box, this is my hundreds box. Yeah? So when we're looking at the abacus, is the same thing how we write. So that's why when we do this, if we did 400, I keep moving it up, sorry. So we do 4,361. So, and again, just like here, we have our indicator saying that this is our thousands. Miss Lynette, can you line it up with the bead? I think so, like that. Am I doing it like this? Yeah, like that. And then like this. It's getting a little hard. Yeah, it's getting a little hard. It's just more numbers. Yeah, it's just bigger numbers. So when we look at it, like that, ooh. So we have our ones, right? That's our ones. This is our tens. This is our hundreds. And then this is our thousands. Yeah. It gets harder because there's more numbers. And when you get more numbers, it gets more confusing. So that's why when I do questions, I try to make it more just single digits. But then people are like, that's too easy. It's like, no. We got to go through the small numbers. We got to go through the single numbers first in order to understand. I think the issue is that not everyone realizes that the ones placement can change. Yeah, I think that was my mistake. My mistake was I kept moving my ones. So I can be my ones over here. I can be my ones over here. Yeah, I could see that. Thank you, Gina. Yeah, they don't know where the reading is. Yeah, I could see that. It could be that too, because it was also in the middle of my in the middle of a thought process. What happened to Grace? She hasn't messaged and showed the time. What happened to Grace? I don't know if Grace was here. I know Lady E, but Lady E probably left. Okay. Does that make sense? Okay, so we're okay now? So in the place value, we have our ones, our tens, our hundreds, and our thousands. So then when we're adding, we would add here. Oh yeah, that was probably what it is. So when we're adding, we would add here. So we have 1 plus 3, and that would be 4. And then we have 5. So 4 plus 5 is 9. So that would be it. Are we okay with that? Whew. She had a hard time, I think. So she got off. Ah, I'm sorry. That's too bad. But it's also late, too. Don't forget, it's also... Well, I don't know what time it is for her, but it's also very late. I mean, late and mathing, it doesn't make... It's not, like, the greatest time. Hey, Pollo! Welcome! I haven't seen you in a while. Right. Okay. So we can go into understanding how to plus a 3. It's 3. Yeah, it's still late. Yeah, it's 3. It's a. Can we do 8 plus 6? It's morning here. Thank you, Daniel, for the hearts. 8 plus 6. We can do it. It's a. It's a. It's a. Is it? It is a two-step equation. So here we go. Yeah, see, it's 2:30 in the morning. See, that's what I'm saying. Mathing is relaxing. Okay, let's do it. It's going to be a two-step equation, just so you know. So I'm going to go, you know what? I will go slow. Let me go slow, because I know I talk really fast. Okay, so we have 8. We're going to do 8. We're going to do this. Let me see if I do this. 8. Okay, we do 8, right? Now we need to add the 6. And thank you, your hearts. Thank you so much. Oh, thank you so much. It's a little bit confusing. Yeah, I'm sorry. I'm sorry. I'm sorry. I don't want it to be confusing. I also know I talk really fast. Write it down on paper below the abacus for visual learners. Yes, okay. So we're going to add 8. We have our 8. Here's our 8. Okay? We have our 8. So this is our 8, right? We want to add our 6. To add the 6, there's not enough. There's not enough to add the 6. So what do? When we want to add the 6, let me change a different color. We want to add the 6, there's not enough. So what do? We know how to make a 10. To make a 10, it's plus the 6 is equal to plus the 10 minus the 4. Let me see if I can center that. So what are we going to do? Because we isolated the variable, that's my 6. This 6 is the same thing as this 6. So what we're going to do is we're going to substitute this information into here. So when we read it, right, it would be plus the 10 minus the 4. But 2:30 what I am. Yeah, see? It's really late, Tabby. Mathing at the morning is not good. So what I'm going to do is I'm going to plus the 10. This 10 means I'm going to go to this column. This column means it's 10. So I'm just going to add the 10. So I add the 10. And then I minus the 4. When I minus the 4, this is my two-step equation. Why is it two-step? Because I want to minus the 4. I don't have enough beads to minus the 4. Yeah, but it's also 2:30 in the morning. Whew. All right. So when I want to minus the 4, there's not enough. Why? Because there's 3 beads. There's not enough beads for me to take away 4. So I can't do it. Can the ones place be the first column all the way to the right? Not in this abacus, because it would get confusing when the numbers get bigger. This was in this sort of concept, it would be 4 decimals because of teaching money to children. I mean, I could start using this one, and that would make more sense. We could do that too. Let me finish my thought here, and I'll change my abacus, because it could be the abacus too. So here I want to take away 4. There's not enough beads, so that's the question. There's not enough beads to take away the 4. It's like here in my country. It's my state is Florida. Yeah, see? Okay. So I want to take away the 4. I don't have any more beads to take away the 4, right? Because there's only 3 beads. So what I'm going to do is I'm going to utilize my 5. I can take away this 5, but taking away 5 is too much. The formula is plus the 4 is equal to minus the 5 plus the 1. So here I plus the 5, I take away the 5 and I add the 1. And so then my answer is 14? 14, because I added the plus the thing. That's what it was. Yes, thank you, user. Yes. Yeah. Let me change it to this, because it could be the colors that are overwhelming. So let me do it again. So I'm going to go here. So here is, so I can use it here, right? So I add 8, right? When I add the 8, I want to plus the 6. I don't have enough beads to plus the 6, so I need to plus the 10 minus the 4. So I plus the 10 I have to take away the 4. There's not enough to take away the 4 because there's only 8. There's not enough to take away the 4. To take away the 4, I have to utilize this 5. To utilize the 5, I have to minus the 5 plus the 1. So I minus the 5 and I take away the 1. So then my answer is 14. I think the person didn't understand the last 2 columns were decimals. Yeah, it could be that too. It could also be that it's too, the colors are too overwhelming. It could be that too. Because some people get hung up on the colors. Because there are some people that really see colors. And that could be confusing too. So I could see that. You mean minus the 5, add the 1. Yes, that is what I mean. That is probably not what I said. But yes, you're absolutely right. That is exactly what I mean. Minus the 5 plus the 1. So then my answer is 14. Yeah. Yeah. So we can use it here. The reason why is because my dot is over here. So it'd be interesting. It's just easier this way. But yeah, you didn't say minus the 5, add the 1. You said take away 5, negative 5, and minus 1. Oh, this is a 2-step equation. Thank you, Tabby. Yeah, plus the 1. This is a 2-step equation because the 4 needs to get the next step of equation. That's why it's a 2-step equation. So we did the first one, which was this, which was making of the 10, and then we did this, which is making of a 5. So that's why it's a 2-step. Because the 5 up on top will always be the base number. It will always stay the same. Yeah, okay. I'm not sure about what you mean by it will always stay the same. When I want to add the 4, adding the 4, there's 2 separate formulas. One is minus the 4 is equal to minus the 5 plus the 1. The next formula would be minus the 4 is equal to minus the 10 plus the 6. Let me change it to addition because sometimes subtraction is also difficult. So we could do plus 4 is equal to plus the 5 minus 1, or plus 4 is equal to plus the 10 minus 6. So the beads will always be 5 each. Yes, the top bead will always be 5 no matter what. This will always be 5. I think they're saying that the top bead is 5 no matter what. Correct. This will always be no matter what, 5 will always be this. This will not be 7 or 8. This will always be 5. So we can do, some may not realize the direction of the boot meets. Yes. So when we take away, we remove it from the horizontal bar. This is such good conversation. I thank you guys so much. But yeah, exactly right. Yeah, it all depends on the movement of the horizontal bar. The horizontal bar is this bar right here. Whether we move it to the bar or away from the bar, but that's exactly what it is. This is so interesting. I think my brain is predisposed to do math with real objects. And which beads are counted touching the bar. Exactly. So when the beads, so that's why the top bead is different because it's going opposite direction. Because now with the top bead, it's touching, but we went down. Whereas the bottom bead, we have to go up. So now when they're touching together, when you squish them together, that's when we count it. Yeah. Yeah, because the top bead is minus the up. Yes, exactly. Thank you, Gina. Exactly. And that's a thing, right? Like not understanding how the beads move. And so understanding that the horizontal bar is what makes it counted. So what we do is we squish them together or we push them apart like that. Right? So we if we want to add them, we squeeze them together. If we want to subtract them, we push them apart. Yeah. It's also super late too, as opposed to abstract figures we can for math, but it's a shame they don't teach us this. Yeah, that's the funny thing is in school we're starting to teach kids to use more manipulatives. So some of the manipulatives are these building blocks, and that's what they're using. Or the other things that they're using is they're using number lines, right? They use number lines. So it's two-dimensional. 0, 1, 2, 3, 4, 5. And then you just count this way, right? That's another way. The other way would be using blocks, right? Using an array. So they're also teaching children, they're teaching kids, how to use an array. So if I give you a box like this, 1, 2, 3, right? 1, 2, 3, this is 3, 1, 2, 3, 4, this is 4. How much do I have? The number racks too. Yeah, exactly. Yes, I'm about to go to sleep. Yeah, Tabby. Thank you. This is so interesting to learn. Oh, yeah, you're welcome, user 99. I don't see your username. Tabby, yeah, Tabby, it's like super late. That's a lot to like try to understand when you're about to go to sleep. Come on. That's not good. I don't think I'd be mathing in like at 2 in the morning. I think I'd be asleep by now. But it's interesting, in school, they're starting to go more. Yeah, see, Ethan, you're like in the middle of the day. You should be getting ready for school. Is it Sunday for you or is it Monday for you, Ethan? So going back to this, yeah, that was the thing. Like, I noticed they're starting to go more pictorial, but I think if they went to more concrete, but the problem is some of the concrete stuff that they have is not really class management friendly, and that's the thing. So, but I don't understand is we don't venture into understanding the abacus, and the abacus is a little bit more contained. It's easier to move and it doesn't get stuff. You're teaching me things to teach the kids with. Yes, I hope so. We only have school on Tuesdays, Thursdays, and Fridays sometimes. Oh, that's nice. Play this song about that. I want to see the end of this. Play this song about that. I don't know what song you're talking about. Yeah. So yeah, we could do adding, subtraction, multiplication, and division. So are we okay with understanding the fives? Don got glitchy and I was trying to type that. It's you guys. Holy smokes, man. For me it's like 2:45, 2:43 in the morning for me, but it's so interesting. I'm invested in learning this. Great. You guys are so silly. I was like, honestly, I didn't think anybody would be up this late that want to math. I was just one of those things. I'm like, I wonder who wants to go learn math. And I'm like, I don't know, but we're gonna try. But yeah, it's really interesting. Okay. So so this is the fundamentals, like understanding how to make a 5 and how to make a 10. Let me know. Abacus made math more interesting and fun. Yeah, I like mathing with you. Yeah, I like mathing with you too. User 188. I think it was Ruby, right? Your name was Ruby? Oh, go to bed. Yes, go to bed, Gina. I was going to go to bed too. See, that's what happens when you doom scroll and you get to something like this and you're like, I'm not doom scrolling, I'm learning something. Oh, it's Melinda. Okay, I will remember that. Will I remember that? I will try my best to remember that. Okay, Miss Lynette, I have to go to work if I have all the... we have to do all... I'm sorry. We have to work with 5 all the time. How often do you go live and teach? I go really often, Gray. Ethan will let you know. I'm often on. I'm on often. Because I'm trying to popularize Abacus. And my family's like, why are you going to go live? And I'm like, because I love it. And I can't teach them anymore because they already know it. So I got to go teach somebody other people. Thank you so much for sharing my live. Okay. So let's do some more 5s. Let's do some more 5s. Okay. So the one thing, okay, let's do 2 digits. Let's do 2 digits. It'll be easy. It'll be easy. Okay. Okay. I have 14. Okay. Okay. Just because I'm curious learning about how Abacus is helpful for just basic math or more. As basic as you get. So Abacus is really good at laying the foundation, adding, subtraction, multiplication, division. That's as much as it goes. It'll go to decimals too. You can do decimals, but that's as far as it goes. It doesn't do anything else. But what it does is, because we do the other things like substitution, let's see, partial product, partial quotient, we do number sentences, like all of the things that we did that helps with the next level. So we isolate the variable, the two-step equations, we do multiplication, division, we understand place value, and understanding the process. Because we understand the process, then it makes it better to go into algebra. So learning this, so much fan. Oh, good. Thank you, Tabby. I do appreciate that. It's yes, Abacus is a gateway to complex math. And so because we have a set formulas, because we have a set framework on understanding how to do Abacus, it leads us into higher thinking math. It leads us into complex math because now we laid the groundwork. We now put all the information like how to add and subtract into our long-term memory. We can start utilizing and we can start utilizing like our working memory for more complex math. So what Abacus does is also provides critical analysis. Ooh, I feel like they should teach this in most schools then, because I was not taught this. Yes, I believe that too. That's why I'm here. So my story is I've been teaching Abacus for more than 20 years. I have a learning center out in Monterey Park, and I decided to put this on the internet to see what's out there. So I want to teach my son, soon to be kindergartner. Yes, you know, Leslie, I do have a book to help teach. Sorry, to help teach early kindergartners. After you understand how to read the abacus, we can go into adding and subtracting towards the end of the book. And because we do adding, subtracting at the end of the book, when you're done with this kind of adding, then the next one would be to understand how to add the 5, how to make a 5. When you make a 5 and you understand that, then we go into making a 10, which would be the next book. So it's like a whole curriculum. There's a whole curriculum behind it. I haven't learned this either. It was probably not because it's well known. You know, funny, I probably honestly only had seen it in the movies. Yeah, you know, it's only been in the movies. And it's true. When I first started Abacus, my dad was the one that forced me because he wanted to start a business. And I'm like, why do you want to start an abacus? What does that? I mean, why don't we just start piano, right? And so he told us that my brother and I were to learn abacus. And I'm like, this is dumb. I don't know why we're learning abacus. It's the dumbest thing. But as I continue to learn and understand abacus, it's actually the greatest thing next to sliced bread. And I wish I learned this when I was young. But my kids learned it and they hated it because it was just more math. But I know because they learned it, they have a stronger sense of their numbers, if that makes sense. So, but yeah, I mean, we can continue on with, but yeah, I mean, somebody asked me, well, what kind of profession? Well, I mean, accounting, right? But we don't talk about laws. But you know, abacus is really just the foundation. Abacus is an alternate if your teacher said not to bring a calculator. That's very true, Ethan. That's very true. Okay, this would be great. Next year I will have a preschooler and kindergarten. Where can I get them? Oh, you can get on right now. You can either get on my website or you can get it on Amazon. If you feel comfortable getting it on Amazon, it's there. If you want to get it from my website, the book, you can get the book from Amazon, or if you want a PDF, you can get it from my website. My website is learningwithlynette.com. I'm trying to find paper. That's what I'm trying to do. And if you don't know my, there's a link in my bio. That's where my website is. My link in the bio. I was trying to find like paper that I had written out, but I can't find it. Um, I'm giving you so many hugs because your learning video. Oh, thank you so much, Tabby. I hope I don't want to. I'm hoping it didn't confuse you so much. I could see the basic concept can be applied to chemistry when learning limiting reactants. Yeah, yeah. Okay. Thank you, Gina. Awesome. Thanks so much. Yeah, no problem, Leslie. Hopefully it made more sense. I did. Yeah, sometimes when I go too fast, I know, and I have to like slow down a little bit. So we could do like 14. So like this one, 14 plus 4. So we have 4 and then 14. Again, when we're looking at this, we're looking at the number here. So here is 14 and 4, right? So what is there enough to add the 4? No. So what are we going to do? We're going to plus the 5 minus the 1. So we're going to add the 5 and then take away the 1. So then my answer is 18. So let's take it one step. Let's take it one step further. Let's do, hold on, hold please. Okay, so always 5. So let's do 14 plus 40. Okay, add the 5 plus the minus 5 as needed. Correct. Is there enough? The first step is, the second step is, can we use the 5? So my question is 14, right? But now I'm going to add 40. To add the 40, I'm only going to be in this column over here. I'm not going to do this column. So what does that mean? That means I'm going to be adding 4 to this column. Do I have enough? No. So that's simple. That means I don't have enough. Simple. Right? The next line of defense is, can I add the 5? Is there a bead to add the 5? Yes, I have the opportunity to add this 5. So now the question is, yes, thank you, Gray. So now the question is how do I do it? Plus the 4 is equal to plus the 5 minus 1. So I'm going to plus the 5, I'm going to add the 5, I'm going to bring it down, add the 5, and I take away the 1. I minus the 1. I remove it away from the horizontal bar. So when I remove it away from the horizontal bar, I am now, my answer is 50. 54. Because I never did anything with the 4, so I have to remember. So the abacus keeps track of my numbers, but I have to mentally think about what it is. 5 plus 10 plus 5 because the one bead is on the tens place. Yes, if we want to take it away. Would you always do the ones and the tens columns first? It depends on where my number is. I would always do the tens. Oh, I see. I would always do it from the tens column first. So I'd always go from left to right. It to me, because I've been doing abacus for a while, it would be backwards if I did it ones, tens, hundreds. So in my head, what I would do is the hundreds, because with the way we talk is 41. We don't say 40. So the way we talk is 54. Yes. Okay. So I'm going to do 14. So when I do 14, and then I want to add the 4, I want to add 40. I'm going to add a 40, a 4 and a 0. So when I look at it, I'm going to add a 4 and a 0. When I look at the 4, my question is, do I have enough? Do I have enough to add the 4? See, the thing is don't get hung up where don't get hung up on the terminology of the ones, the tens. Don't, I wouldn't say 40. Like, I'm not taking away 40, I'm taking away 4. And I think that's the other thing that we're kind of getting hung up on. Because in school, we are told, do the ones, do the tens, right? But in Abacus, we do it as a whole. When we do it as a whole, we have a bigger picture. So because we're doing it as a whole, we're only looking at this one digit. So when we look at this, we're only looking at the 4. So on the 4 and the 40, do I have enough? No, I don't. So then what do? I will plus the 5 and minus the 1. So I'm going to plus the 5 and take away the 1. That's my 4. Now I go to 0. So now I have the 0. So my answer is 54. Can we do another one? We can do another one. So we can do another one. Let's do okay, we'll do 23 plus 34. So the first thing we're going to do is we're going to put 23. So we put 20 and we put 3. Okay? We do 23. So we can do the process and then go back to the place value for the answer. Yes, exactly. So what I would do is I would go through all my numbers first and then I would look at it. And that's why it takes me a moment to look at it to see what numbers I have. But that's what I would do because the questions can get really long. So I'm going to add 34. This is a plus. So again, the question is I'm going to add the 34. I'm adding 30. I'm adding the 3. I'm adding the 4. So if you look, I want to add the 3 over here, and I want to add the 4. When I want to add the 3, do I have enough? Thank you, Ethan. Do I have enough to add the 3? This is where I'm at. No, I don't have enough to add the 3 because I only have 2 beads here. So now I can utilize the 5. So the question is, the question is plus the 3 is equal to plus the 5 minus 2. No, exactly. So now I know my formula, my plus 5 formula. The plus 5 formula is plus the 5, take away the 2. So I add the 5 and I take away the 2. Now I'm done. No, I'm not. I still have the 4 to do. So next, when I go here, right, I know I'm going to go to this one because there's my 3, there's my 4. Again, do I have enough? No. So what am I going to do? I'm going to plus the 4 is equal to, put in the comment, what's the formula for this? Plus the 4 we're adding the 4, Gray, not the 3. It's the 1, exactly. So it's because we're making a 5. See, this is why it's key to understand how to use the 5. We make use of the 5 now? Yes, because now we can. We have the ability to make the 5. So it's plus the 5 minus the 1. So when we do that, yeah, right? So we plus the 5 and we take away the 1 because we can. Right? So now our answer is 57. 57. Oh, okay, you know what? We can do another one. This will be a good exercise. Let's do our times table, right? 4. Thank you so much for the hearts. 4 plus 4 plus 4 plus 4, right? We know this, right? This is what's it called? Cumulative add-ins. Add-in something. Cumulative addition. That's what it is. Cumulative addition. Why is the first one minus the 2 and the other one is minus the... Oh, because I'm doing a 3 and I'm doing a 4. The 3 to make a 5, right? When I want to make a 5, these are the numbers I'm using. So when I want to isolate the variable, I need to take away the 2. The 4 is the same thing. Plus the 4, 1 plus 4 is equal to 5. When I want to isolate the 4, I have to take the 1 away on the other side. That's why. So what I just did was I substituted this goes into here, and then this one goes into here. So that's why it's a -1 and a -2. So you take away however many it would take away to make a 5. Exactly. Exactly. So that's why this is the formula that we would have to memorize. We would have to make sure in order to make that 5. So when we make a 5, and that's why we're taking it a notch, taking it a notch, taking it a higher notch? No, I don't know. Stepping up a notch. There it is. Stepping up a notch. The formulas are pretty easy to memorize. The formulas are easy to memorize if you understand. Yeah, fact families. The formulas are easy to understand if you understand why we're doing it. I feel like if you understand why we're doing it, it makes more sense. If we just memorize it just to memorize it, then it'd just be like memorizing doubles. But the idea is to understand why do we need to do it and what's it for. Because then we can actually critically think how big our box is or what our solution is. When we understand how to do things, then we can think outside the box. Miss Lynette, the bear on the 4th column to the left is 5,000. Yes. 1, 2, 3, 4, 5. Yeah. Tens, no, ones, tens, hundreds, thousands, 10,000. Oh, I understand. Is the formula to be, if the formula would be 34 plus 23, would it still be the tens of the -3? No, yes, it would be. Because, because, because now you're looking at the 2. So, let's take a, let's workshop this. These are fantastic. Thank you so much for all the questions. So we have 23, right? See, now it's different. Why is it different? Because we're looking at the add-ins. What is the numbers we're adding? We're adding this number and this number. So that's why it's different. You're absolutely right. So now the questions are different. So when we want to add the 2, it's plus the 2 is equal to plus the 5 minus 3. And then this one, is plus the 3 is equal to plus the 5 minus 2. So it all depends on the add-in of what we're trying to do. Thank you so much for sharing the live. Thank you so much for sharing the live. I do appreciate it. So did that make sense? So yeah, exactly. It all, see, that's why it's so interesting. When we teach the kids, we always teach the kids the result, but we actually need to do is we need to look at the process. It's only the process. It's only about the 2 and it's only about the 3. And that's what's really interesting. So it's a different way of thinking, but in algebra, we learn the process. So when we do adding and subtracting, we always focus on the result, but we need to take it a step back and understand the process. When we understand the process, it's good. So let's go back to the question. 4 plus 4 plus 4 plus 4. Why are we doing this? Because now the 4 has many different ways. You can either plus the 4 is equal to plus the 5 minus 1, or you can do plus 4 is equal to plus the 10 minus 6. So now we can go through our scenario. The first one is, let me add the 4. Is there enough? I'm over here. Can I add this 4? Yes. Check. Not a problem. Can I add this 4? No. Does it go hand in hand with making change with cash when you only have limited number of bills? Yeah, it can be. I think so. I mean, that's what it was originally used for. Right, Gray. No. The second 4 we need to plus the 5. Yes, exactly. So can we add the 5? Yes, we can add the 5. So what are we going to do? Plus 4 is equal to plus the 5. I'm going to show this. Plus the 5 minus the 4, right? Plus the 5 minus the 1. So I plus the 5, take away the 1. Now I have 8. And I add another 4. The question is can I add a 5? Whoa, you can't see that. Let me move it down. Can I add a 5? No. So this is the process of elimination, right? Can I add the 4? No. Can I add the 5? No. Can I add the 10? Yes. Right? I can add the 10. So I'm over here. I'm going to add the 10. What is it? It's plus the 10 minus the 6. So I plus the 10 and I take away the 6. So then I'm left with 12. So plus the 10 minus the... Yes, exactly. Exactly. Not enough beads in the first column. Exactly. Exactly. So I'm done with this, right? We're at 12. I'm going to leave a running number. So now the question is, I want to add another 4. Do I have enough beads to add a 4? No, I don't. What do? That was simple, right? I don't have enough beads. What do? How can I add a 4? Exactly, Leslie. Exactly. Plus the 5 minus the 1. See, that's what I'm saying. When we understand the formula, it's really easy to put it all together. Oh, yeah. And then the answer is 16. I told my kids that they had to do it this way to memorize their multiplication. Break the 4 down using 5. Break the 4 down using 5. Break the 4 down using 5. Yes. But what it was is using doing the multiple add-ins like this. The cumulative add-in is to show the process of critically analyzing what we were trying to do. Right? We could do the same thing with 3s. We could do it for all the numbers. Are we ready for a times table? Are we ready to do multiplication? It makes a lot of sense when we do the cumulative adding. Yeah, right? It makes a lot of sense. I feel like I feel like I'm doing statistical data. Yeah. Okay. Are we ready for multiplication? Because you can do multiplication on the abacus. I don't know. No, I'm not ready for multiplication. Yes, we're ready for multiplication. Yes, cumulative. I understand what you're saying. I can't spell. I can't. Fractions too? You know what fraction? What fraction is? Fraction is this. This is a fraction. So what do? We just change it, right? 2 and then like that. That's a fraction. Really? Maybe? Okay, no. We'll do it. Let's do it. Let's get uncomfortable. Okay. The question is 92 times that by 9. This is going to be easy. This is not a problem. Easy to use. Difficult to... No, it's not difficult. It's not difficult. Can we do simple multiplication first? Yes. This is the most simplest you can get. Why? Because it's 1 digit, 2 digits by 1 digit. There's no point for me to say 4 times 3. There's no point. Because you just need to know your math facts. So the one thing about this is Abacus, we don't memorize 12 times table. You know what? Let's do that. So 12 times table. 12 times 4. 12 times 4. The first thing we're going to do is we need to find our starting point. To find our starting point, why? Because we need to know where we're putting our answer. Where are we going to put our answer? So to do that, we just count the amount of digits we have. 1, 2, 3. So I'm going to start here. Can I start here? I'm going to start here. 1, 2, 3. So I'm going to start at the hundreds column. Was like, ooh, dang. You guys, you can ask Miss Alex to explain more. Yes. Yeah. Okay. So let's do this one first. Let's do 12 times 4. Easy, right? Because we know this. Now, the reason why I'm starting at the hundreds is because I have 3 digits. It depends on what my answer is, will let me know if I need to go back and forth. What does that mean? Well, 4 times 1 is equal to 4. 4 is a single digit. So I need to go back to 1 column. That's what that means. So 4 times 1 is equal to 4. So I'm going to add my 4 here. That's it. We're done? No. So what I did was this. 4 times 1. My next one I'm going to do is 4 times 8. I put my finger here because that's where I left off. So because I left off, I'm here. So now the question is 2 times 4. 4 times 2, 2 times 4 is 8. 8 is a single digit. Ooh. Why is the 4 in the tens place? Because 4 is a single digit. When 4, because a single digit, it would be like having a leading 0. So it would look like this, like that. You'll understand it sooner or later. Ethan. Ethan's been with me almost from the beginning. So he's had a few hours of this. All right. I got to stick through it. Yeah, trust the process. Trust the process. But the thing is understand the process. You need to understand the process. So the reason why is what we're going to do first is 4 times 1. When we do 4 times 1, right? 4 times 1 is 4. 4 is a single digit. If it's a single digit, we take it back 1 column. It's 3 a.m. God, you guys, this is nuts. You guys, it's like 3 a.m. What time do you gotta wake up, Gray? Holy cow, man. Okay. Holy cow. You guys are crazy doing math at this time of hour. Okay. Thank you so much for liking my liking my live, Nicole. Okay. So, thank you, Liz. Thank you so much for the rose. I don't okay. Okay. We're going to continue mathing. So, are we okay here? When we do 4 times 1 is equal to 4, either we can write it as a 2-digit or understand that we have to go back. Hey, Ghoulie Foolie. I've seen you around. User 9977. That's all I see. Okay. So, we're back to here. Do we understand that this is a 4? It's a single digit. When it's a single digit, we will go back 1 column. That's what that means. The only reason why we go back 1 column is because 4 is a single digit. We can make it double digit. Would that be easy? It's easy to do division too. Ethan's really pushing the class forward. Blame Ethan. So do we understand why we move back 1 column? We add the 4 to here, to the tens column, because 4 is a single digit. Yes. So now we do 4 times 8. Same thing. 4 times 8 is 4 times 2 is 8. 8 is a single digit. I go back 1 column. Why? If we were to make our 8 a double digit, there would be a leading 0 like this. That's what that means, right? It would be a leading 0. Because there's a 0, I go back to this column and I add 8. So there's my 8. So my answer is 48. That's it. So we can go to the next one. It might be easier to do this one. Why? Because it's double digits. Double digits, we don't have to go back and forth. So thank you, Apple user. Thank you for liking my live. Okay. Is it okay if I start here on this column? Or do you want me to go to the colorful abacus? Is it easier to see on the colorful abacus? Okay, I'm going to I'm going to start in the middle. I like the colorful one. Okay, I'm going to go back to the colorful one. I like the colorful one too because I feel like it's the beads. You know what I noticed? I don't know if you noticed, but I noticed that the beads on this one, the height of the beads is not as long as this one. So I feel like you could see better that these are being moved. That's what I see. Okay. So this is my ones. Now what am I going to do? I'm going to count how many digits I have. How many digits do I have? Right? We're going to continue. We're going to figure out where we're going to put it. Right? How many digits do I have? Please put in the comment. 3. Thank you. Thank you, Leslie. 3. Yes. Okay, good. We're okay. So 3. Now the first thing I'm going to do is 9 times 9. Yes. Yes, it is, Gray. So 9 times 9 is 81. 9 times 9 is 81. So I add my 8, right? I add my 8, and then I add my 1. So I'm going to keep my finger here where I left off. I'm going to stay here. Why is it not? We could, but because we started over here on the hundreds column, we start from the outside and then we go in. We can go backwards like the mainstream math, and I'll show you what happens. We could do this, but let's do it this way first. So here, my next question is 2 times 9. 2 times 9 is 18. So I add 1 and I add 8. My answer is 8 to 8. So why did you do? Oh, because I did. It's the same thing because I go outside first and then in. So in 12 times 1, you did. Yes, I did. I did 4 times 1 first, and then I did 2 times 4. Yeah, that's what I did because I go outside first. Now let's do the other way. Let's do the other way. I feel like it's so easy, right? Yeah, when you get it, it's like, oh my God. But it does take it a little bit, but everything takes a little bit, right? So let's do it the other way. We don't need to count. We don't need to count how many digits for the other way, right? Why? Because we're going to do this first, right? So if it's a double digit, that's what the distribution, yes. What we're doing right now is called distributive property. And that's an algebraic term, I believe. So let's do this first. So we have 2 times 9. 2 times 9 is 18. I already wrote it here. Now the problem is, if I start at the ones, I'm now going forward to go back. Why? Because I have to say 18. Notice my finger goes 18, not 8, 1. We don't say 8, 1. We say 18. So that's the reason. That's one reason, right? And then it gets really complicated when you have more numbers. But I'm gonna go with it, right? So we have 18. So I add 18. I have to go forward 1 to add. So I have my 1, and then I have my 8. My finger is here. Now what do? Now I got to do 9 times 9. 9 times 9 is 81. What do? Well, 81 means my 1 is going to be over here, my 8 is going to go over here. So that means I got to go up to 2 to add my 80, and then I add my 1. So this is why it's a little backwards, because now you got to think backwards when you do it this way. Does that make sense, Jay? That's why when we start, we always go outside in because the way we talk. We can do double digits after this. But yeah, did that make sense? How would you do it? That you would just have to memorize that. How would you know if 2 times 8 is 18? That's something you have to memorize. You have to know your multiplication math fact. I mean, we could do the cumulative addition in order to see it, but other than that, you would have to memorize your math fact. Okay. So let's do another one. We'll do another multiplication. We'll do 2 digits this time. No, we'll do 1 digit. We'll do 1 digit. We'll do 18. We'll do 18 times that by 6. right? Again, we're going to start on our third digit. 1, 2, 3. I'm so confused on the one-digit ones. So if we didn't memorize the math fact, then we would have to factorize 9. Oh my God, you just used some big words I don't know. Then we would have to factorize the 9. I don't know what that means. Sorry. What part? I'm confused of the ones digit. Yeah. Doing it this way? Yeah, it gets really confusing. Like LCM. Yeah. I don't know how that would pertain to abacus. I'm still trying to think about the concepts being used in algebra and how it relates to abacus. I'm not there yet. I haven't marinated on that part yet. Gray, are you confused about the mainstream math way doing it or the abacus way of doing it? Yeah. Yeah. Yeah, I was thinking about the LCM, but I still have to sit on that for a little bit. It takes me a little bit to connect everything. The mainstream. Yeah, that's why the mainstream one gets confusing. That's why it was only used this was only to show why using it on the abacus is confusing. That's the only reason why I did it. But usually we would do it this way. We would start from the outer first. So that was just to demonstrate why it gets confusing, and it can get confusing really quick if you did it the mainstream way. So here we start from 3. 1, 2, 3. And the first thing we're going to do is 6 times 1. 6 times 1 is 6. 6 is a single digit. So if we not pretend, but if we rewrite this to look like 0, 6, right? This is 0, then 6 goes here. So we add 6 to this. Then what's next is 6 times 4. 6 times 8. 6 times 8 is 48. So notice, for multiplication, we applied facts we already known. Yes. So multiplication, we need to know our math facts. We need to know our multiplication math facts. And then it gets really solid really quick. Because the questions in Abacus it just goes on top of each other. So I want to add the 4. There's not enough to add the 4. Notice, this is why we're putting 6 in the tens. Exactly. So now what we're going to do is we're going to put the 10 minus the 6. And then, don't forget, we're going to add the 8. So now we go over here and we add our 8. See? Yes, because the problem has a 10. Yes, exactly. See, and that's the reason why we would have to build on our 5, making of the 5 and making of the 10. So that when we do the adding, subtraction, multiplication, and the division, it becomes easier. But don't forget, because we're pushing through, right? The kids don't do this right away. The kids takes time to do it, right? It takes time to understand. For every one digit should be 0. Yes, if it's a single digit, I would imagine it to have a 0, a leading 0. Yes. That would be the only way to keep track of the columns. But yeah, and then so, again, we're pushing through this because, so is the answer 108? Yes, the answer is 108. Is the answer 108? Yes, the answer is 108. 108. 108. Yep. Yeah. I mean, the kids, so after if I had a student that started at 3, they would know their numbers till they're 4. They would know their formulas at 5. They would learn their multiplication tables around 6, 8, the age of 6, and then they start doing like the actual adding, doing the multiplication division when they're like 6.5. If you want to know what the timeline is. Some substitute or apply the factorization to lead the invisible 0. Can we do 37 times 4? Yes. Those are really big words, Jay. I'm so lost. Sorry, that didn't sound right. I do. Yeah, those are really big words for me. I'm not that smart. I just know abacus. That's all I know. All right. So our starting point is 3. 1, 2, 3. How do I know? How do I know? Because I'm counting the digits, right? 1, 2, 3. So I'm going to put my finger here, and I'm going to times it. So the first thing I'm going to do is 7 times 3. 7 times 3 is equal to 21. This is easy. 20 and then 1. Why is it easy? Because double digits are easy. 7 times 4 is 28. So all I got to do is add 20 and then I add my 8. And that's it. Why? Because there's no formulas involved. This is a very simple multiplication. All we did is just move the beads. That's all we did. So we replaced the leading 0 with the number we're working with in the tens place. Well, this got more simple than I thought. Yeah. J. The only reason why we do a leading 0 is if it's a single digit. That's it. If it's a single digit, that's why we have a leading 0. That's it. There's nothing more to that. Don't overthink it. Yeah. Great. This is the simplest. This was a really good one. But see, that's the thing. Like, you wouldn't know looking at it, looking at the question, whether it's a simple question or not. That's why sometimes we struggle, because we have to, like, foresee the questions. So, what about 99 times 99? Really? All right, we could do it. We could do 99 times 99. 99 times 99. Can we try double times a double? Personally, I prefer this over the multiplication I was taught. So abacus is not multiplying in the bead. It's applying the math. Yes, exactly. Using the addition. Exactly. The abacus only tracks the numbers. It doesn't, there's no arithmetic involved in the actual abacus, if that makes sense. So, Leslie, can we try double times a double? Okay. Only tracks the digits. Exactly, Jay. Only tracks the digits. Okay, Ethan. Let's do it. Where's our starting point? This was, I don't know if this is going to be easy. I don't know the numbers well enough to say if it's easy or not, but we can work it out. So where are we going to start? 1, 2, 3, 4. The fourth column, exactly. 1, 2, 3, 4. Okay, the first thing we need to do is we're going to do this. 9 times 9. So sorry. Thank you for understanding. No, don't be sorry. It makes a lot of sense, because some people think that abacus is meant to do like the actual arithmetic, but it's not. It's really, if you really bring it back to the bare bones, like the simplistic sense, it's only to track your answer. 81. So 9 times 9 is 81. Equals to 81. Yes. Nah, I think people think abacus is witchcraft. Hey, I need to go shower, go to bed, but I can't stop watching. 81. All right. We're here. Now we're here. We got to do it again. 80, 5, 6, 7, 8. 81. Right? I agree. I thought it was witchcraft. Yeah. There's actually a logic behind it, which is really quite amazing. Like it's really interesting how simple it is to be so complex. Because when we do math, there's a lot of like strategies. There's a lot of strategies and things to go. And this is now just a rant. But I don't understand, like, if there's so much strategies, I don't understand why we don't try to use the abacus a little bit more. Yeah, go back. All right, let's do it again. So we have 4. We do 80. And then we add 1. I did this one. The next one, we're going to do this one. We use the first digit in the second set of 9. Yeah, in the second, yes. So we do this one and this one. So let me change color. Now we're going to do this one to this one. So we do 80, we add 80, and then we add 1. That's it. We're done with that. I'm going to change color. I feel like changing color helps also. Now the first thing we have to do is we have to find our starting point. Why? Because now our number has changed. Our question has changed. So our question is now, how many digits? 1, 2, 3. So we look. 1, 2, 3. I'm over here. So we start in the third column. Yes, Ethan. Oh, wait. I'm waiting. Hey, CJ. Welcome in. We're talking about multiplication on the abacus. The 3 digits and start on the 3. Yeah, from the left. Yes. From the left. Yes. So we're now at the hundreds column because we have 1, 2, 3. Personally, I wouldn't do 99 because there's too many 9s. I would have changed the numbers. But this is the question. So I'm here. So we're at the third, and again, we're going to add 81. We add 8, we add 1. Yeah, it's harder to see because the numbers are they're too similar. We can do another, we'll do another one after this. When we're adding 81, you know what? What if I did this? What if I did this? It would be 8, 9, 1, 0. This is what I have right now. Right? So now I'm actually going to put my finger here where the 9 is. So yes, Leslie, yes. So in the problem, we use the amount of places according to the number of the problem. Yes, correctly, Jay. Yes. So we're here. We're going to add 81. We're adding 81. 8 here, 1 here. 8 here, plus the 10 minus the 2. And then we add the 1. Right? So now our answer is 9720. So now I'm here. Oh, I'm here. Right? Do we see those numbers? 9720. So now I'm here. I'm going to add 81 again. 81. Do I have enough? No. So what do? I plus the 10. Yes, exactly. I plus the 10 and I take away the 2. And then I add the 1. So now my final answer is 9801. Yes, Gray. No. Not 8, 9, 9, 8. Almost. No worries. Yeah. But it gets confusing really quick. Yeah. It gets confusing really quick because the numbers are very similar. When the students do it, I have a running total. Just kind of like this. Because it gets more numbers. But we can do another one. Let's do another one. We can do another one. Let's see. Do you guys want to try another one? Reviewing for fun. Excuse me. Okay, that's a good one. Let's see. 47 times that by 32. Again, what are we doing? 4 digits. 1, 2, 3, 4. So I'm over here. So 3 times 4 is 12. Yes, using 4 places. Yes, we're at the thousands now. So 3 times 4 is 12. I add my 2, my 1, and then I add my 2. I add my 1, and then I add my 2. What did I do? I did this. Right? Then the next one, the next one, I'm going to do this. 3 times 7 is equal to 21. So do you need to memorize all the numbers? Yeah, we just need to go, when we memorize our multiplication fact, we only go up to 9. Because after that it's redundant. So we add 21, we add 2, and then we add 1. So what do I have now? I have 1, 4, 1, 0. I didn't line that up right, but you know what I mean. So I'm already done with the 3. Don't need to worry about that anymore. So what I'm going to do is I'm going to cross it out just to make sure I remember not to use it anymore. Now what I'm going to do, I have to find my place value. 1, 2, 3. Column, yes, 3 columns. So 1, 2, 3. So now 2 times 4. 2 times 4 is 8. 8 is a single digit, right? 8 is a single digit. If we made it a double digit, it would look like that. So we add 8. 0, 8. There's enough. 5, 6, 7, 8. And then 2 times 2 times 7. 2 times 7 is 14. So I'd have 1 and I had 4. I plus the 1. This is more than 2 steps. How do I know? Because I want to add the 1. What's adding the 1? Plus the 1 is equal to plus the 10 minus 9. Plus the 10 minus the 9. Plus the 10. I cannot plus the 10. What do I do? This plus the 10 can be plus the 1 is equal to plus the 5 minus 4. Does that make sense? So we're going to substitute this into here. 5 on top. So this is a 2-step equation, right? So that's why we have to be really solid on what we're trying to do. So I want to plus the 5 minus the 4 minus the 9. That was this. And then I want to add the 4. So the answer is 139? No. The answer is not 139, Ethan. The answer is 1,504. Yes, Leslie. Exactly. Make sense? We always need to factorize to the least number base for every single number to apply it. And apply it. Oh my God, Jay, I have no clue what you just said to me. That's like Greek. I don't know what you just said. I'm loving this. Oh, thank you, Leslie. Yeah, when you get it, you get it, right? J, the number of beads according to the place. We always need to factorize the least number using base 5 for every single number and apply it. I honestly have no understanding what that means because I don't know what factorizing means. I guess that's what it is. I don't know the terminologies like factorizing. Are we trying to make it the smallest? Because I don't see how we're factorizing. I see that we're multiplying it out, right? So is it the smallest? No, it's not the smallest because 2 times 4 is 8. So then you will have 12. I don't know where you got 12 from. 4 times 3. So what I know what I did here is called distributive property. I know what we did here. You use prime factorization to break the simple form. Oh, is that what I'm doing? Okay. I know. When will you be on live again? I'll be on live tomorrow. I use 12 as an example. I'm on live quite often, Leslie. Uh, yeah, I'm on live quite often. Usually around this time, early morning, late at night. Sometimes I do like middle afternoon too. Um, so yeah, I mean, if you follow me, you'll get notified. Yeah. So so Jay, I don't think it's factorizing. I don't think what we're doing is factorizing. I think what we're doing is called distributive property, because what we're doing is we're taking 4 and 7, and then we're adding it. So it's 4 times 3, right? And then plus 7 times 3. That's what we're doing. I have to go. My first day of work tomorrow. Yeah, no problem. Thank you so much for staying on live. I will see you. Yeah, I'll see you tomorrow. Not a problem. I will be on. Thank you again. Have a good night. Good luck on your first day of work. Let me know how it goes. It'll be fun. It'll be interesting to see. Bye. We should try division. Are we ready for division? Um, Jay. So we're back to Jay. So when you're doing it, so it's not factoring. It's distributive property, because we have this and then we do the 2. So when we do the 2, it's the same thing. 4 times 2 plus 7 times 2. Is that what we're doing? I don't think it's factoring. I think what it is I don't think that's factoring. I don't know. Make, I think. We can do division. I'm just waiting on. Did that make sense, Jay, or no? Wow, there's still 9 people here. You guys are nuts. You guys are really committed to mathing in the middle of the night now. Yeah. So, Jay, does this make sense? That's what I'm doing here. It's not. I don't think it's factoring. I think it's called distributive property. Where we do it. Because I think factoring is when we make it smaller, but we're not making it smaller. We're making it bigger. Okay. Well, while Jay's thinking about it, I will do division, which will be our last question, and then I'm gonna head to bed. I'm gonna head to bed. All right, I'm gonna keep that there, and then my last notebook paper. Then I gotta get a new notebook. Yeah, this is my kids' notebook, and then I just used up all of their papers. So, anyways, I have a little bit in the front. I could do the front. Okay, question. Let me go look for it. Let me go find a question. Because division's a little bit more. We won't do that one. We'll do this one. Okay, we'll do this one. This would be easy. Maybe that's too many. Okay, we'll do this one. So 4 divided by 2. Okay. Again, the first thing we need to do is we need to find where are we going to put our answer. That's what we're going to do. Where are we going to put our answer? We are going to put our answer, we got to figure it out. Now, in multiplication, right, we added the numbers. Now in division, we're going to subtract the numbers. We have our divisor, which is, I'm going to say S is our divisor. Because there's a lot of, I just got to label it. So then there's 1 digit is our divisor. And then there's 3 digit is our dividend. So our dividend is E. And there's 3. There's 3 digits, 1, 2, 3, in our divider, in our dividend. And then there's 1 digit in our divisor. So 3 take away 1 is equal to 2. So I'm going to start at the second column. When I start at the second column, this is where my answer will be. So what I need to do is I need to put our dividend on the abacus. Because we're gonna do subtraction. We're gonna use the dividend on the abacus to subtract. So we have 2. Have a good night. Have a good night, Melinda. I hope that got, yeah, it was Melinda. 214. 214. So what I'm going to do is now I have to compare. Now we're going to have a conversation with our question. The first thing we're going to do is we're going to set up our divisor and our dividend. To do that, because we have to compare. Our divisor is 2. So our 2 and our dividend is also 2. So this is 2. They're the same. If they're the same, we got to go to the next column over. So if you pretend there's a 0 here, and this is a 1, our dividend is bigger. Because 0 and 1 is bigger. When the dividend is bigger, this is a formula. This is a rule. When the dividend is bigger, we use one column, and we only use one column, and we need to skip this column. Use one column, skip column. So I'm going to be over here. So the question is, 2 times what is equal to 2 or less? 2 times 1 is equal to 2. So I put my answer, 1. And I take away 2. What am I doing? I'm thinking. That's what I'm doing. Because I was thinking, maybe I should show you how to do it long division as well. So, 2, 1, 4. So here, in mainstream math, we don't have a conversation. We just say, we just know we're going to take away 2. I don't know how we know. I just know we know. So this is the question, right? So now, I still have dividends, right? I still have dividends. Oh, I still have dividends. I still have dividends. We go back. We're only going to use the 1 to compare. 1 is my dividend. 2 is my divisor. Who is bigger? My divisor is bigger. So when my divisor is bigger, then I use 2 columns. 1, 2. I use 2 columns. So that's where, because you cannot take away 2 from 1. So that's why you have to use 2 columns. So now you can see what times 2 is equal to 14 or less. I got confused. Yeah. It takes a little bit. Because I'm taking two columns, same. I'm thinking. Let me find a different number. Let me find a different question. Because the problem with this is there's too many comparings. Okay, let me find another question. The answer is 107. Okay, let me find another question. Let me see. Is it this one? Maybe I do. Okay, let's try this one. Okay, 7010, divide that by 2. Let's try this one. Okay, I will take a rain check. I'm listening. I will think on it. Okay, let's try this. Let's try this one. Let me see if this one is a better question. See, and that's the thing. I have to find the question that makes more sense because of the different rules. So when we look at it, where's our starting point? 4 take away 1 is 3. 1, 2, 3. This is where I'm going to put it, but I got to put my dividends. My dividend is 7, 0, 1. So who is bigger, divisor or dividend? My divisor is 2. No, maybe that's not a good one because we're still comparing. No, I want to try to find a different one. Hold on. Hold, please. Maybe I try this one. Okay. Yeah, here. This is a better one. This is a better one. Oops. Okay, this one's a better one. Okay, let's do this one. Where are we? 24, 249 divided by 3. So where do we start? We start, there's 3 here, there's 1 here. So 3 take away 1 is equal to 2. Why do we start at the 3? We don't. Let me change the question. We started at the 3 because I had more numbers. I'm just going to start it again. Sorry. Yeah, that was the other one. Yeah, no. Yeah, because I was just thinking that was more comparing. So this one's a little bit more easier. Why? Because now the divisor is bigger. So what are we going to do? We're going to find our starting point. Our starting point is 2. 1, 2. So we're going to put our dividends onto the abacus. 2, 4, 9. Make sense so far? So the question is, who is bigger, divisor or dividend? Our divisor is 3, right? Our divisor is 3. Our dividend is 2. So when our divisor is bigger, we use these 2 columns, right? Because you can't take away 2 from 3. So we need 2 columns. We need to use 2 columns. So that's one of the rules, is we need to use 2 columns. So the question is, 3 times what is equal to 24 or less? 24. 4 times 8. 3 times 8. So 3 times 8. I'm going to add 8 here, right? Yeah, 8. And I take away 24. Take away 2. Take away 4. Now the question is who is bigger? 3 or 9? 9 is my dividend. I guess this is not a good question. My divisor is 3. So my dividend is bigger. So I take one column. I take one column and I skip one column. That's a rule. So then we know 3 times what is equal to 9 or less. And we add 3 and we take away 9. Was that a better question? It's getting late. Yeah, 3 times 3. I get it a little. Yeah, it all depends on the questions you start with. If the questions are too big, then it gets really confusing really quick. So, but yeah, the answer is 83. Yeah. Dandelion, how are you doing? I didn't see you there. Yeah, it got confusing really quick. It was a great overview. Thank you. Yeah, I feel bad when people get confused, and I don't want it to. I don't want it to give anybody a bad taste. I've been lurking. I'm gonna go to craft an abacus for myself to practice. Oh, here's the thing. When you do, make it 5 columns. That's what I would do. I would make it 5 columns or 6 columns. I wouldn't just do 1 column. I'd do 5 columns, 1, 2, 3, 4, 5, and I'd have it in the middle. Or I wouldn't label it. I don't think there would be a need, but I would make it 5 columns if you're thinking about it. You shouldn't feel bad about confusing people. My teaching always confused me, and don't even care. Ah, that's not good. You just said something that made something. You just said something that made something make sense to me. Okay, Dandelion, what was it that made sense? No, but even with anything, I like to simplify. Oh, so you did buy the abacus from Daiso, so you did have one. Hey, how much was it at Daiso? Um, Gina, I don't know where you are, but you might want to check out Daiso to see if they have any abacus, because I got the 13 one from Daiso. This is one I got from Daiso. Yeah, yeah. It's really about how the teacher works. But yeah, I do feel bad when people get confused. It was like 3 including text. Yeah, okay. Oh, I have a couple of Daisos around the blocks away. Yeah, you might want to take a look at that. It would be a 13 column most likely. Yeah, if you don't want to get it from Amazon. But yeah, Daiso was good too. So just so you know, the ones from Daiso would be plastic, right? That's why it's cheap. Yep, just like this one. Yeah, this is a 13 column one. This one came from Daiso, I believe. But it's still Japanese made, which is interesting. And it's good. I like it. I was just thinking, I like it, except I wish that the columns were bigger. I wish that they were a little bit longer, which is interesting because these are the same height, but I think maybe it's because the beads on this is smaller, so you could see that there's a bigger difference. See that? Yeah, I don't know if you can see that. Yeah, I was thinking about it, I was noticing there is a considerable amount of difference between the beads that are in comparison. So, but yeah, I do like this one just because the beads have a longer positioning. But yeah. All right. It's like 4 in the morning, whoever's on the East Coast. I'm gonna yeah. Oh, well, sure. Ask away. Yeah. Yeah, no problem, Gina. Yeah, let me know if you want to, if you make one, I would probably make one that's about 5 columns, if not more. Okay. Dandelion? Can I hear you? Hold, please. I don't know if I can hear you. No, I should be able to hear you. I don't hear you. Did I cancel her? I canceled. Oh, sorry. Try it again, Dandelion. I thought I... Mute? No? Add as moderator. I don't know. Did I cancel you? I don't know what I'm doing. I don't know how to. Oh, maybe it's a. Here. Is it this one? Oh. Accept. There we go. There we go. Here we go. What's up?
There you are.
There you are. Yes.
Okay. So you just said something and I was like, but I have to say it to you again and make sure I got it right so I can make sure I understood it. So, wait, move your abacus out of the way real quick so I can see the numbers that you wrote down. Okay, so you said the divisor, you're talking about
Devise.
the top one, the S3E2 right there.
Yeah.
And you said that if the divisor is bigger, the 3 goes into the 2, but the 3 can't go into the 2, and that's why you need 2 columns.
Yes.
So that you're putting 3 like into 20. Is that what you're doing?
3 into 24.
Okay.
So like long division.
So the second one you can put 3 into 9, but the
Yes.
first one you can't put 3 into 2. So
Correct.
that's why you need 2 columns.
Yes. This is why
Oh
you
my
need 2
gosh.
columns. So
Okay.
so that was the thing, like in regular school, we don't teach them why we use 1 column or 2 columns. We just tell them, how do you divide 3 into 249?
Well, no, they say, can you put 3 into 2? No. So then can you put 3 into 24?
Oh, okay, so they do that. So it's the same
They
thing.
do that. But
Okay.
I didn't get that when you were, I couldn't figure out what the 2 columns and the 1 column and why. But now that just made perfect sense. So you have to add that to your book because that made it totally make sense to me. You know, you said you were writing a book for adults.
Yeah.
You got to include that. That's the reason why you need those 2 columns. Like it is a rule, but that's why the rule makes sense. You see what
Okay.
I'm saying?
Yeah. Yeah, I'm just kind of I'm trying to formulate and think about the division. I'm not even there yet. I'm still trying to figure out the adding and subtracting, but okay. So adding the 2 columns, but I was thinking, see, I think if I was to do it for adults, I think I would do it like this and then show the difference.
Right,
Yeah.
right.
Right.
But I'm just saying when you told us about the S means that if the S is bigger, it needs 2 columns.
Oh, I
Like
see.
that
Right.
didn't completely make sense to me
Right.
until tonight. You just said because I've been listening to you do this for like 2 weeks. So
Yeah.
until you said that it's because the 3 won't go into the 2, that's when it clicked into place for me.
Oh, I see. I see. Yep. Okay, got it. I see.
Because before that, it was just a rule I was trying to remember.
Right, right, right. Right.
But
Right.
now it makes sense.
Okay. Okay. That yeah.
I love that. That's amazing.
Yeah.
Thank you.
Yeah, not a problem. Not a problem. Thank you. Yeah, I appreciate it because that's one thing, and I think that's why I really enjoy going live, so I can be better at communicating in my books.
Yeah. Well, I love, just coming on here every now and then and saying, hey, that thing right there, that's so cool.
Yeah,
Yeah.
yeah, yeah, and that was the thing. Like I was just thinking about, and I was just telling my husband about it. Like the reason why I go live is because there is the interaction. Whereas if I go live on like other platforms, I don't get the interaction like I get it here.
Yeah.
So
Yeah.
I do appreciate it. Thank you.
I learn something new every time I pop into your live. Thank you. It's like
Thank
I've been watching so long, sometimes I'm like, oh, I already know that. And then you say something and I go,
what?
okay, what? Wow. Okay.
Yeah, Whimsy, we are back. We're not back, actually. Whimsy, we're actually going to close up shop because I've been on for about almost 3 hours now.
All right. I'm going to say good night.
Have a
Thank
good night.
you.
Yeah,
I
not a
love seeing
problem.
you again.
Okay.
Okay. Bye bye.
Bye. Oh my god, Leslie, I just got back too. Oh my god. Go to bed. No, it's like 4 a.m. Yes, it's 4 a.m. Go to bed. You guys are nuts. Mathing, rest in peace. I will come back on tomorrow. I decided to do my lashes. You're so silly. Oh my god. But I was planning to stay up till 5 a.m. But I gotta go to sleep. I can't lie. I've been thinking about Abacus all day after your live this morning. You guys are funny. I'll be back tomorrow. Yes, I'll be back tomorrow too. I'll be back tomorrow. Oh my god, Whimsy, that's so funny. Math, Abacus math all day. Thank you so much. Tomorrow it is. Tomorrow. I will come back tomorrow for sure. I wanted to learn division. I missed it. We will do division again. It's not the last time. I hope you have a good night. I hope you have a good night too. Have a good night, everybody. Thank you again for joining me and being here and having a conversation. I do enjoy all the conversations and the comments. I do appreciate it. Thank you guys, everybody. I will see you guys tomorrow. Tomorrow it is. I'm going to head to bed. Good night. Thank you so much for the likes. Good night. Ah, doing your lashes, Leslie. That's so funny. Okay, okay. Good night, good night.